Hello, welcome back to Cracking the Cryptic. And yesterday we released the puzzle hunt, The Labours of Rostam on Patreon. Do join us there and see that. It's proving very popular. There are 7 puzzles. Puzzle 2 is quite hard, but you don't have to take that on second, or indeed until the end if you want. And I think it's puzzles 5 and 6 that are proving tricky after that. But do give it a try. It's getting a lot of very good reviews, which we're delighted at. A lot of entrants as well. A bit easier than the last few months is what we're hearing. So that's good news for those who want to enter. Less good news for somebody who entered early on and said, well, I liked it being easier, but I guess that means that we're competing against more people for the prize, which would be the chance of a collaborative solve with Simon on the channel. And there'll be one of those up in a week or two, I think. So good news. Now, we've also, of course, got Crosswords and Connections on Patreon. We've got Sven's Sudoku pad on the links under the video. And also all of our apps, which feature Line Sudoku and Domino Sudoku and Killer Sudoku. And, of course, they feature Fog of War, which has been very popular, and the Worms. So do check those out. Extra content, great for a summer holiday. But we're doing a debut today. So this got sent to us by Bluebird Broken Leg. That reminds me of the swim bird that keeps turning up in the Blue Prince house, but I dare say it's nothing to do with that. Bluebird Broken Leg has sent us this puzzle and said that this is how they would like it to appear. So, although you will see from the rules that some of these areas could have been represented with lines, this is the constructor's choice of appearance. And I'm going to go through the rules now. Normal Sudoku rules apply. 1 to 9 in every row, column, and 3 by 3 box as normal. In an orange square, the sum of the digits inside the square must equal the number in the top left corner. 8 there, and we can have repeated digits, which might explain that 8. In a green square, we have an effective whisper line. A digit in a green cell differs by at least 5 from a digit in an orthogonally adjacent green cell. So it's a bit like a green square line around that. Then we've got red squares with quadruple digits in. A digit inside the circle appears at least once in the 4 cells touching that circle. A blue rectangle, which is a Renban area, effectively. It contains a set of digits that are consecutive and all different in any order. There's a yellow square with 2 palindromic lines in it. So each of those is a palindrome and reads the same forwards and backwards. It's 2 lines, it's not 1 line. And there are some white dots on which a pair of cells connected by a white dot forms a pair of cells connected by a white dot are consecutive digits. Oh, and there's a diagonal. Digits cannot repeat along the diagonal. Now, I did a puzzle with quite a lot of rules a few days ago, and the response was reasonably positive. I think as long as the rules don't have major innovations as well as loads of other rules, a lot of people, not everyone, but a lot of people are quite used to the rules and quite like the interactions. So we're doing it again. Thank you, Bluebird Broken Leg. Is it a tongue twister? For sending us this. I'm going to have a go now. We're going to see how we get on. You can give it a try on that first link under the video. Let's get cracking. Well, 8 and 28 are very different cage totals. Let's start there. So 8, you couldn't get. So if you assumed 1 and 1, and you might have to have that, not quite, but nearly, then the other digits would add up to 6. And you certainly can't have a digit, well, yeah, the other digits would add up to 6 and couldn't be 1s. You're never going to get a digit more than 4 in this box, in this cage. This box, very differently, 28, I think, has to have a 9 and an 8 in it. It's either 9874 or 9865. 9 and 8 are X-winged, aren't they, with this K? But since this straddles 2 boxes, that may not be quite as helpful as I was hoping. I don't really know where to start with all these possible rules that might help. It's quite difficult to know where to get going. Those are low. I want to say there's definitely, well, there's certainly A1 in this group. Is that any use? No, not really. Or we could point out that there are 4 low digits there, and there must be 2 in that area and 1 there. No, I don't think so. This blue is the Renban, and is therefore either a set of the digits 1 to 8 or a set of the digits 2 to 9. What do we do with that? I don't know. These digits obviously are 3, 7, 8, 9 in some order. I mean, in these columns, that's going to give us a... Oh no, these aren't 1, 2, 3, 4. Those are the candidates. Oh, that's a bit different. There's no X-wing on 3s necessarily, because there might not be a 3 in this group. Ah, okay. The fact that there's a 3 there does rule out one of the possible makeups of this 8 cage, which is 1, 3, 1, 3. Now, we know there's a 1 in here because you couldn't do it with 2, 3, 2, 3. That would add up to 10. I think we know, now that we know it's not 1, 3, 1, 3, now we know that there's a 2 in here as well. In fact, does it now have to be 1, 1, 2, 4? I think it does, you know, without a 3. And you can't have any digit more than twice. That's what it is. Oh, interesting. Right, so this is a 1, 1, 2, 4 group. And we've definitely got 1 in each of those areas. Now, the low digits on this effective German whisper line cannot be 1s. Is that any help? Is that any help? Yes. I think also, oh no, it crosses boxes. In this green area, hang on 1 second, sorry. So in this green area, I know that we couldn't possibly have 3, we couldn't possibly have 4 or 6, because they would have to touch 2 digits that see each other. In this green area, we could have 4 or 6. In theory, because 4 could touch 9 on both sides. However, we couldn't actually specifically have 4. Oh, that's quite interesting. We can't have 4 or 6 in this area either. The reason we can't have 4 is because there's a 4 there and a 4 there, and that's going to use up the 4s in the 2 rows. We can't have a 6 either, because a 6 would need to be flanked by 2 1s, and we've actually used 2 1s here already. So we can't have a 7 either, because a 7 would have to be flanked by either 1 or 2 twice in this area. And we've used both 1s and 1, 2 for the rows already, so there aren't enough. Therefore, the high digits can only be from 8 and 9, and we can only have 1 each, because that area has 1 each as well. So it's rows 3 and 4. So the high digits are 8 and 9. The low digits, this isn't so obvious, but they can't be 4. Oh no, they could. No, they can't be 4 because 4's been used twice. So the low digits are selected from 2 and 3, but they could repeat. Well, 2 couldn't because there's already a 2 being used. So there is at least 1, 3. Oh, it's very difficult to keep track of this with pencil marks. Oh, this is nearly a blooming quad as well. I can select 1, 2. I still could have 2 3s and an 8 and a 9 in this area. it's a very strange puzzle the way these these restrictions play together. Now, there's a 4 here, but what is the 4 doing? I don't know. Actually, the quad is the least, the quadruple cell is the least helpful place. Dear me. Right, there's a 5 and a 6 in the central box, and they have to go in blue. That means they can't appear here again. What else does it mean? I don't know. Let's briefly have an excursion into thinking about what happens if this is 9, 8, 7, 6, 5, 4, 3, 2. Then the remaining digits that have to appear not in colours in these rows are 1, 1, 2, 4, 5, 6. Just those. 1, 1, 2, 4, 5, 6. That is possible. I was wondering if you couldn't put 1, 2, 4 here, which is sort of true, but not actually helpful. Okay, it was worth a thought about whether we could say that there was definitely a 1 in this zone. This is not a quad if there's a 2 there. 4, 8, 9 appear here with one other digit. I mean, 4, 8 and 9 are therefore X-winged out of these cells. So is 1, not necessarily 2. Either 2 or 3 are X-winged out as well. So of 5, 6 and 7, one of them could appear here, but the others, and there are 5 other such digits in these rows, must appear in these 6 cells. That's really strange, but I think it's definitely true. 5, 6 and 7 have to appear somewhere in these rows. It's strange. Why am I so fixated on that? Because I haven't really got much else to be going on, I suppose, but something's going on there. Something odd is happening in regards to that. Now, what about 9 and 8? One of those digits is high, and therefore 9 and 8 can't both be there. One of them must be over here. Whichever is high there appears over here. I don't know, there's almost enough to actually do something, but not quite for me. So I need to think more. Now, maybe I briefly wondered in my head whether this is 9, 8, 7, 4, and then all of 9, 8, 4 would be sort of X-winged, but I don't know where to. It could be into box 3 or into box 6. We've also got, now, here, what did we say? You could have 3s as long as, you can't have 4s or 6s. So we're selecting from 1, 2, 3, 7, 8, 9. Over here we have 9, 8 and either 7 or 6. And here we have a double pair. That's quite interesting. I haven't actually thought about these palindromes. Oh no, they're not the same. Yes, the same 2 digits that appear there, of course, in the other order. So, what are we not allowed to have 2 of in yellow in these columns? 1, 2, 4, 3, 7, 8 and 9. Oh, it's so obvious. This is a 5, 5 and a 6, 6. And therefore, both 5 and 6 appear down here. And now this cage doesn't have 5 and 6 in and is 9874. And these digits are selected from 1, 2, 3 into the bargain. Now, we've used one each of 9, 8 and 7, so we can only use one each here. We only need 2 of them, but we can only use one of each type. Also, does this not do anything for the column? Not really. That is 5 or 6, and that specific item can't appear here, but it doesn't mean both can't. Right, so what else is going on in green here? I don't know. That pair, well, if they're looking at this, that doesn't really mean anything. I think it means these can't be specifically from 1, 2, 3. Okay, 9, 8 are. 9, 8 and 4 cannot appear here, but 8 and 4 must be in blue somewhere because the set of digits overlaps 4 and 8. So there we go. That is a 4, 5, 6, 8 set. We can't have 8 in those cells, so we must have a 9. Therefore, the 9 on this in this red area is up there, and there's no 9 here. Therefore, there is an 8 up here, and the 8 in this red area is down here. Now, here we have to use 2, 3, and 7, and an extreme digit. The 8 that we've put in there has to come out of here, and is definitely in these two. Now we do have a 2, 3, 7, 9 quad, and that digit is a 1. Now, there is a second 1. It's good that I remembered that, in the 8 cage. So those are a 2, 4 pair. And that, we've got 2 digits in the puzzle after 13 minutes. I know I'm not doing this particularly brilliantly, but there we go. Now, one of these has to be a 7. And therefore neither of these are a 7. And what about here? 2, 3, 7 and 1 or 9. Maybe 4 is here, but we don't know. Oh no, we do know that 2 is here, don't we, in this box? Yes, we do. That's the only place it can be. That's going to be very helpful, actually. So we get rid of the pencil marks. 2 and 9 are looking at that cell, which becomes a 4. That's a 2 to make the cage work. Now, 9 comes out of these now, and therefore 3 comes out of those. It feels like there's a lot more certainty around, but maybe not much else has been done. The 4 goes up here, along with the 9 now. And 8 and some other digit are there. Right, remaining digits in row 3 are 5, 6, 7. Remaining digits in column 3 are 2, 3, 7. And that's got to be, it's not a quadruple, I'm quite wrong. However, 8 and 9 and 4 are still to place in box 1. The same digits as appear on that quadruple, how strange. Oh, I don't know. Okay, these digits are from 3, 5, 6, 7. I've got this whisper to fulfill. That's quite interesting. I haven't done anything with that. And I don't know what I can do. Oh, 9 has been used there and there, so it's not in this blue area. So this is 1, 2, 3, 7 now. And that digit can't be 3 or 7. 1, 2, 3, 7... 4, 9 can't be in here. So we've found a 5, 6, 8 triple. And that's a 3, 7 pair at the start of the row. These digits are a 1, 2, 5, 6 quad. Yet another unmarked 2 by 2. Right, that's a 4, 9 pair in the box. 4, 7, 8, 9. 5, 6 and 1 of 1, 2, 3. Oh, this column. Yes, I need an 8 in that column. That's easy. And then there's a 4, 9 pair at the top. Then we have another little 2 by 2. I'm tempted to colour these extra 2x2s that I'm finding. Not that they're actually a feature of the puzzle, but since they're blocks of the say of 4 digits that I'm going to have to arrange at some point, I find that quite amusing. So 4, 9 here. Do we know about this white dot, or this one, or this one? I don't know, you know. If that's a 2, this is 3, 4. If that's a 3, this is 4, 5. If that's a 7, this is going to have to be 8, 9. And all of those seem possible. Up here, I don't know. We said it couldn't come from 1, 2, 3 because that would break this pair. We also can't use 4. Okay, that's interesting. And we can't use 9. So these are selected, from, good Lord, from 5, 6, 7, 8. And we've got a quad. And the 8 is on the dot, so that's an 8-7 pair. I mean, I didn't work that out very skillfully, but I got there. 5-6 pair down here now. Now, in this row, didn't that do something? No, oh yes, it does. It means one of these two is a 7, and therefore there's no 7 in these. That's good. Now I get the 7 in column 3. This is really neat, isn't it? I mean, you've got to be impressed by how this goes together. Haven't tried the diagonal yet, and that's going to be very helpful once we get any digits on it. Now, on this white dot sequence, this is either 6 or 9, but it can't be 9. So that's 6. Now we've got a digit on the diagonal, and you can look on the diagonal while I'm doing other things and see what it's doing on the diagonal. We've got a 1, 2, 3 triple there just by Sudoku, 6, 7, 8. That can't be 6 or 7, so that can't be 1 or 5. Here we've got a 2, 3, and that can't be 1, so it must be 4. Oh, hang on, have I done that? Yeah, that's fair enough. I was worried that it wasn't kind of a sequence where I knew the two, but they happen to be consecutive anyway. So this is all working. I haven't looked at that diagonal yet because I have had other things to do. That's a 2, and they're not. Now, there's no 5 there. I'm keeping on doing the other things for the time being, and I'm going to run out of steam on them. Okay, so let's look at the diagonal now. Yes, a 7, you will have seen this a while ago. It's looking down at a 3 there. That 3 looks back at a 1 there. That 1 does not touch anything else. However, there are a 5 and 6 on this diagonal. And one of them is there, and the other one can't be here because 5 and 6 are already in this box. So it must be the central cell, it must be the other of 5 or 6. We've now got a pair. We need an 8 on the diagonal. That's going to have to go here. This digit is from 2, 4, or 9, and in this cell it can only be 2 or 4 because we've got a 9 up there. Now this is odd, can't be 5, so it's 1 or 3. Yeah, that's a 2, 4, 9 triple. One of those two is a 9. Does that do anything? Not on its own. 6 has come out of those. 2 3s come out of those. And these, are they? No, 5 and 6 at the bottom are done though. That sorts out 5, 8. Now 8 comes out of this one. It's funny how once you get going, there is a lot to do. Okay, that was a lovely run of activity, and I'm not going to say it's a juddering hole. I still have not used. Right, what are the high digits here? We can't use 6 or 8. The high digits here are 7 and 9, and that's X-wings with 7 and 9, virtual X-wings. The 2 7s and 9s in row 7 and 8 are being used up between green and orange, so that's going to have to be a 9 in the bottom row. I thought that was going to help. It didn't really. Right, 7 and 9 are in use here. 7 must touch both of the low digits, and they must therefore be 1 and 2. So these two are a 3, 4 pair. That puts 2 in the corner. That doesn't solve that, but it does sort the 2, 9, 4 trio on the line. Now, we can take 9 out of those cells, 4, 7 out of those. 9 out of those, 2 out of those. What about this 5, 6 pair? I don't know. 6. These are from, that is 1 or 3, and weirdly this becomes a 4, and that looks at a 7 here. Then I can take 7 out of these cells, and I've got a 1, 2, 3 triple, making this a 9. That's unexpected in this puzzle. It isn't really how the rest of it has worked. Quite surprising, that. Probably doesn't continue on. That can't be a 2. Oh, it can't be a 3 either, so that's a 1 in the corner. That 2, where is 2 in one of those? We've done all the white dots apart from that one, which I can't finish off. Oh, there's a bit of Sudoku left. One tiny bit of Sudoku to do somewhere. 2 can't be in those cells. Or maybe it's to do with this bit of diagonal stuff. Should I be colouring 5s and 6s? Those 2 are the same. I don't know. I don't really think that's it. Maybe it's to do with this 1, 2, 7 triple. Oh no, I got this 3 and 7. I haven't used them in the rows. That's probably what it is. 1 there. No 1 here. No 2 there. So the 2 is placed in this purple. 2, 7, 1, 3. 4, 5, 6, 8. I don't know what's happening there. In this row. 2, 7, 1, 3. Oh look, there's a 5, 6 pair has turned up in the row. Unexpectedly. How about this row? That seems less helpful. Can I use that for, look, that's a 3, 4, 8 triple in the column. Oh, this suddenly gets confusingly Sudoku. Right, 5, 6 pair there now, so this is 4 or 8. I haven't used this 2, but maybe I can now. No, I can't. This is the only cell in the, no, 2 cells in the puzzle with 3 candidates. Oh, it's so strange. It feels like it's done and I can't see. Oh, the 1. No, 1 is in one of those cells. Goodness me, is some version of this going to fail and the other version going to work? I don't understand. Or if I, oh no, it's the German whisper thing, isn't it? It goes round in a square. I could have done that up here as well. I just basically forgot. Because the rule is that a digit in a cell differs by at least 5 from a digit in an orthogonally adjacent green cell. So that could not have been 7 once that was 9. That's how it works. Right, so we're all done now. We just fill in the remaining digits with less surprise that it works. Because we just have to read the rules sometimes to actually understand what it is we're left trying to do. 7 and 6. 6 and 5. That 6 on the diagonal is going to sort out my yellow area when I get back to that in a moment. And that moment is now. That's a 5, touching a 5, 6 and 6 because of the palindromes. 9, 8. Let's just get rid of my whimsically drawn purple areas, and this is a 4 and a 9. And there we go. And from 13, so over half the time of solving that puzzle, I had no digits in the grid. But then it came together, very neatly put together, Bluebird Broken Leg. You were quite whimsical as well in not having green lines and a Renban purple line, but there we go. That's the way some people like it. Thank you for watching as always, and we will be back with you soon, tomorrow. But do try that Labours of Rostam hunt on Patreon if you can. People are really enjoying it. See you then. Bye for now.